We're running about 5 minutes early. That's okay. I was commander of MDRS 124. It was the first half of the Euro and Mars A and B series. And what I basically want to go through is what makes a good analog suit, about how the suits compare on this mission versus my first mission back in 2005. How you can carry gear on these suits, because with the backpack being taken up by the spacesuit backpack, you kind of limited your options. Some proposed solutions in the short, medium, and long term, and trying to keep, on the one hand, maximum fidelity and maximum innovation, but on the other hand, trying to keep any budget considerations from the Mars Society to an absolute bare minimum, if not zero. So the main issues you have with these spacesuits is that they are intended to make your work more inhibited. You have vision limits in terms of your field of view as well as your ability to see through the thing. You have hearing limits because of the fans blowing in your ears. You have tactile limits because you can't really feel things with a glove. On the early missions, they had you would tie strings to tools because with the heavy ski glove and with the kind of loose pockets, people were dropping gear. And you couldn't hear the fact that your hammer dropped while you were hiking along. So if the string was there and you felt it drag, then you know, oh, I dropped my hammer. They leave you insensitive to weather, which if it happens to be really windy and cold is a great thing. But if it happens to be that you are trying to fly a drone or something, and you have no sense of which way the wind is actually blowing, then you have to do everything by visual cues. And in the desert, there are no leaves to blow, and there's no grass to blow. It all just looks exactly the same, whether it's windy or not. So the only thing you have is whatever the drone is telling you. And the other issue is that the center of gravity, hiking in these things, especially in rough terrain, can be very dangerous. And we'll get into that. So what makes an analog suit good? The three principles from the very beginning of MDRS were safety, sim, and science. You don't want anything that shifts your center of gravity too far away from, too far backwards or up, because then you will become less stable while you're doing any of this obligatory rock climbing. The helmets offer minimal protection on the ATVs. They have changed the policy to where you can switch to a motorcycle helmet while on the ATVs and then switch back again, which helps safety but interferes with sim. Heat exhaustion is a big issue if you're in, if it's especially sunny and if it's especially warm and you're wearing full street clothes underneath your suit and you're on a very long hike, you have to be prepared for the possibility of breaking sim because of heat exhaustion. But on the other hand, you want the simulation to be good for accuracy, and you also want to be able to actually do geology or whatever else you're doing out there in terms of doing any actual science. So this is the suit from 2005. The items in green on one side, the forced air vents and so forth, the collared helmet, those are all still there. However, the original suits had paratrooper boots with lead weights in the fields. Those are gone. You now bring your own boots. You'd think lead weight in your heels when you're hiking a long distance would be a terrible thing, but when you're hiking and you're climbing up these muddy cliffs, the ability to have additional swing weight in your heel to plant your foot is actually really good. Because it's like having an axe as opposed to having a little pick. They used to have large ear pockets, which were good for carrying stuff, but bad for dropping stuff because they weren't very well closed. A lot of people would duct tape a GPS to their forearm. Now with smartphones, we don't really deal with that. You used to have a nameplate on the front, and the radio gear was integrated. You had a push-to-talk switch on your neck. A lot of that stuff on the one side is gone. The negative of that is that you have, the simulation is not as high a fidelity. You're using sort of a conventional off-the-shelf jumpsuit with hardly any pockets on it. The comfort level is increased because you're putting some of your own gear, but the realism is sort of a little bit lower, which requires a more disciplined crew to stay mentally in sim. My crew were anywhere from very strict about it to very loose about it, and it was very hard to get the loose cannons back in line. So this is me demonstrating about as much gear as you can carry on one of these things comfortably. I'm carrying a hydration pack with pockets looped through the chest straps on the backpack. This has two advantages. It shifts your center of gravity forward. So normally a backpack would pull you back. This would kick you back to a normal upright gait. Therefore, you're not burning energy in your lower back just trying to stand up straight or leaning forward like a hunchback, like most backpackers have to do. I was able to use a holster down in the belt, and I actually brought a belt from a utility type belt from home, so that I wouldn't be putting stress on the backpack belt. But that allowed me to carry a full hammer drill comfortably for many climbers. And then on the other side is my SLR bag, where I had a full SLR that just went off, and I'm still playing with. So I was able to carry a full iPod in that and sample containers in the center pouch. And that's, like I said, that's about as much as you can do. Some crews have taken the hydration packs and put them on top of the backpack. I don't like this idea because it shifts your center of gravity up. I was also doing something where I would just hook it directly through the belt. Your center of gravity is typically about here. So anything you do that moves your center of gravity above that line decreases your stability. Anything you do that moves it below that line increases your stability. So having the drill down here helped a great deal. Having the backpack, having that chest pack moving through the side, it was abrading my leg, which was not good, but it lowered my center of gravity so that when April and I would do any kind of rock climbing, I could traverse things a lot faster than she could, just because she was constantly bobbing that thing around, you know, like putting a weight on the end of a pole trying to balance it. That's what she was doing with her backpack. Had she attempted to climb a very steep sort of rock climbing thing, that could have pulled her right over. So these are our options. I just took something out of Google SketchUp and just put boxes in to show the approximate locations where things can go on the core. You'll notice in this thing we've got the option of actually strapping things directly to the backpack. This is not done very often at MDRS because there's not really a good way to do that. The other reason is that those boxes that hold the fans and so forth are plastic, and consequently we don't really want to add a load to a plastic box and canvas bag, because it's not good for the plastic box, and eventually you're going to end up cracking them. So any kind of gear loading like that you would do at MDRS, you would do very lightweight equipment, if at all. As I said, the chest pack is a good option. These are the options on the arms and legs. Again, any kind of momentum you have with anything, the further out it is, it's like anything else, it's like a vehicle or anything else. If you put momentum here, it doesn't take a lot of motion. There's not a lot of motion to add inertia, to add energy loss. If you put weight here or you put it on your leg, you're burning calories moving it every time you move it. There's a reason that, one of the reasons Macintosh, for example, has not put a touchscreen on Macintosh is that they want to avoid what's called gorilla arm syndrome, because if you have to do this to a screen constantly, this becomes very ergonomically difficult in a relatively short period of time if you do it constantly. That's why the mouse is down here. If you put your arm above your heart level, it's always, there's always a time limit. If I put my arm like this, there's going to be a time limit of how long I can hold it like this. If I put it like this, it's going to be a much longer limit. So it's the same sort of thing here. If you put weight out here, you're just going to add inertia to the whole thing. So I originally started a long series of charts and so forth about this, but I was able to consolidate it into one mildly interesting one. On the left side is the accessibility of being able to reach these pockets. Going back to what the previous speaker said about being able to reach or being able to restrict mobility, when I was working this out, I was thinking, well, if you had stuff on your chest, that's great. But if you had a low, if you had restricted mobility because the pressurization of an actual spacesuit, you would want your pockets across the pack because you couldn't reach the ones on the same side. You would have to reach across for everything. But if you had a skin suit or something, you could reach the same side very easily. I'm sorry, Joe. Oh, sorry. Easy enough. So we have visibility, in other words, can I even see this pocket? The load limit of how much gear can I carry there. Obviously the chest pack, you can probably carry about 22 pounds there very easily. The hip and belt, you can carry a lot of weight, but not a lot of weight, certainly not on the backpack because of the reasons I gave, at least in MDRS in its current configuration. Not a whole lot on the shins and forearms. But for the forearms, to this day, it's a great thing to have any kind of electronic display or interface on the side, as long as you can use it with one hand. Multi-touch display is a little more complicated. And so forth. We're just working down the list here. Forearm would be a good place for monitoring equipment that you can just turn on and turn off, but that you don't have to look at. So like for the heart rate test, that would be a good place to stick equipment. Any kind of radio gear on a backpack and so forth. So going forward, there's something that, it's a NATO military thing called MOLLE gear. It's basically a modular system for clipping different pouches onto a backpack or a chest pack or whatever. This is a pouch here. It's got two clips on the back that go through a series of webbed lines. And ironically, Bishop Heiser here just happens to be carrying a duffel bag with the other half of this component. And I'm just going to hand this around to you. I'm just going to hand this around. That gives you an idea of what that looks like. And that's a pack on the side. Something that a few crews have played around with are drones. Around the time I was working on this paper, my brother, unbeknownst to me, had purchased a $120 drone that shot high-definition video, but it shot it to a memory card. It didn't transmit it to the map. So he sent me a whole series of pictures from this quadcopter of his house and so forth. I'm like, oh, that's pretty cool. And then I got to the last slide and I was shocked, because he's holding the drone like this, and it's smaller than a dinner plate. And it was shooting high-def video. And if you don't necessarily want high-def video, they're down to around $80. So the only negative is like any other kind of little toy helicopter, it'll charge for 5 minutes, it'll fly for 5 minutes but charge for 45 minutes. So it sounds like a one-shot deal, but if you just put a USB charger like we have for cell phones and so forth with the pack, then there's no reason you couldn't clip this thing to the backpack, charge it while you're hiking, and then if you come up to an inaccessible cliff, have your crewmate pop it off, fly it up the cliff, shoot some video and so forth, and then clip it back in, put it back on the charger. If you see another spot where 45 minutes later, you're in a good position to shoot video of that as well. And then the other thing is getting into smartphones, and we're going to get into that a little bit more detail. So how can we go even further in this technology range? On the one side is one of my crew members with a little drone that is, or a little rover that is at MDRS and has sort of a Wi-Fi camera arrangement. It was donated by the Northern California Mars Society. It was a little temperamental, that's why she was pointing at it like a strict mother. And then another shot from one of the Desert Rats things from NASA where they're experimenting with rovers like that. Background 2005, 2006, NASA did a lot of experiments at MDRS. They did at least 2 seasons, I'm not sure. But they would bring out these gigantic rovers with GPS. They would bring out tons of Wi-Fi antennas. They would bring out a big satellite dish with, to communicate back with headquarters. They brought out their own backpacks and so forth that were compatible with the MDRS system. But what they were doing was, instead of using the family radio system, they were using Wi-Fi voice over, basically voice over IP. So they could talk to each other, they could talk to the rover, they could take, and by the end of this sequence, they started out kind of crude, but they got really advanced really fast. They could do things where they could take the camera and they could say, take the picture from my camera and email it to Steve Squires at NASA headquarters, or wherever, whichever office he works at, and it would just do it. Or at least it theoretically could do it.
It did.
It did?
Sometimes I get data pictures of them.
I see. Okay, it works. Okay. So you get the idea. But
It did quite too well.
This took 3 moving trucks of equipment and God knows how many millions of dollars worth of gear to do it. And that's a panorama shot by that drone at the bottom. Well, that was 2006. That's the drone panorama with the geotag up in the corner giving the latitude and longitude and time and so forth. That's a panorama I shot with my iPhone. And that's a geotag that I took of a sample location. At the top is the UTM coordinates. At the bottom is the exact bearing, the azimuth and altitude. This is just a $10 app called the Autolite for the iPhone that I was able to use at MDRS. So if we can do that, the only thing we're missing is the rover. Oh wait, we have the University Rover Challenge. So there are now a couple dozen of these things at least in the possession of different universities, whichever ones are still working. Okay, if the thing's been around, just set it on the chair. Okay. So what's to prevent them from setting up a rover with a little bit of terrain following year and bringing some out of retirement after the University Rover Challenge? They've already put 16 grand into these rovers. They might as well get some further use out of them and maybe have something where the science committee and the University Rover Challenge have some follow-up work where they pick up where NASA left off 8 years ago. So that was the key point, a sort of university-level Deadwood Rats arrangement. And then we've got other technologies. We've got mini drones, like I said. We've got Google Glass coming out next year. We've got Pebble watches that you can now buy, which give you a real-time display of whatever's on your iPhone or whatever on your wrist. So you don't have to actually have, you can have a remote display like I was talking about. The R4 is really good for displays. And for the students involved in this, it's an excellent resume bullet because they've now done what NASA was doing, not even 6-7 years ago. High Seas has actually made their own analog suit. I'm not quite sure where they got this, but it's excellent in general. But it has a lot of, you notice a lot of MDRS influences in here. You've got the big box shoving air into the helmet, so forth. But my issue here is if they bought any off-the-shelf parts, I would love to know where they got them. Because that would be a good thing to incorporate into future MDRS suits. And then the other thing is that both that suit that I just showed you and the MDRS suit are based on Apollo, which what NASA's been doing lately is they've been doing these backpack entry suits, where you leave the suit outside, you open the backpack, walk in, step into the suit, close the backpack, step off the vehicle, and come back and reverse the process. But you've got a hard torso piece, you've got an integrated helmet, you've got this integrated hinge, you've got a lot of very expensive things that would be very difficult to simulate. But maybe we can fake it just a little bit. If we take, because the first thought I had was, well, how do we simulate that hard torso piece? Well, for $52 off Amazon, this is a bicycle motocross chest protector. It's got a front piece, it's got a back piece. In the crudest form, you could probably clip a backpack into the back piece or a chest pack into the front piece. It would distribute, instead of having all the weight on the straps, you would have it distributed across the entire chest cavity. So that would be good. The only difficulty is I would not want it to look too aggressive because we don't want to look like, between that and the mall gear, we really don't want to look like Starship Troopers unless we're trying to appeal to the Xbox generation. But it might be possible to cannibalize that, maybe not have a side hinge, but maybe a top hinge, and just be able to pop it like that and so forth. It would require a new custom suit with big puffy sleeves and so forth, but I think it's probably worth researching. I don't think we would build more than 1 or 2 of these because I can't imagine them getting that cheap. But if we want to simulate what's really being considered for Moon and Mars missions going forward, it would be nice to have a suit that actually looks like, does the part. So in summary, there's a lot of things that we can do now with the suits exactly as they are, with zero budget allocated for that sort of thing. It's perfectly smartwatch compatible. I'm sure you can get Google Glass under that helmet, no problem. I would like to see maybe a Wi-Fi communication system instead of the family radio system, provided you're able to set up little base stations, even if you leave them in sequence. Again, this is something that you could integrate with the rovers. As a secondary option, rumor has it there's actually, when I went there the first time, there was no cell phone signal whatsoever. When I went in February, there was a spotty signal. There was a rumor that somebody had installed a 4G antenna since then within range of this have. If it's true, Shannon said no. But apparently it's become easier to get a signal out there. Yeah, exactly. And that's an excellent point. It would really, really, really break SIM to have your cell phone doing something that your cell phone would do on Earth, like getting a call from your girlfriend or whatever, or getting a text message from, there's a new sale on gas, whatever. So we would want to avoid that sort of thing. But in general, what we could do is have apps that are specifically for going Wi-Fi only, not using the 4G network, or that would use the 4G network but would block out the regular phone functions. And again, I mentioned the quadcopter option. And then the volunteer, the advantage of that is that pouch that I was handing around, what's preventing you from just buying a pouch that matches your gear? If you're taking a rock hammer, take a pouch compatible with a rock hammer and some sample containers. Bringing it with you to MDRS, having a vest there at MDRS to clip all your gear into, and then you don't have to worry about any of these issues with, oh crap, where do I put this thing now? And then, as I said, an advanced modular suit would be a good option going forward, and then possibly the chest protector, which also would assist in ATV safety at some point. So, any questions?
Your university level proposed project is pretty similar to like the one you got our conference. So maybe if we could talk after this,
Okay.
it's almost like designing a spacesuit, which is Google Glass computer and quadcopters are open. I think pretty similar to what you're doing.
And his thing was he's working on a project with Google Glass rovers and drones. So, or at least we're proposing one, or
We can talk after this.
okay, he's got ideas along those lines. I have a feeling some of this is inevitable. So it's just a matter of, even if this suit looks exactly like it did in 2005 or pretty close to it, we're still doing advanced science that we weren't capable of in 2005, or at least nobody's short of NASA was doing in 2005. So in that sense, a lot of the advanced technology concepts that they may look stagnant, but they're actually becoming incredibly advanced based on the career that people were bringing with them. So, yes, Shannon?
I would also like to talk to you at some point because the MDRS spacesuits are currently being redesigned. You have all new suits in this upcoming build season. And you have a lot of ideas that I would like you to share with the team that's doing that. And I'm also interested in being the first person who's put it to me in a way, we've had this big deal with smartphones when we were here. What can we do with that? And for some reason, the way you presented it, I would always think completely separate research segments of what we're doing at DRS that should be multiple tools. And maybe we'd like to leave that and get involved with something like that. I'd be really interested.
Okay, the head of the science team has just informed me I've been drafted.
Exactly.
Any other questions?
Yes, you are integrating or proposing to integrate all kinds of recent technological achievements like solid glass and things like that. How is this related, or is it related at all to operational scenario which we are foreseeing for Mars, because finally we would like to simulate Mars operations? Or are you just saying, well, we try out all the recent available technology, and then later on we see if we can use it or not on Mars? I mean, this interrelation with this actual Mars operation, because if we are continuing like that, we will never come to an operational concept on Mars, because an operational concept on Mars will have to be settled years and years before you ever start the final development for Mars. You see what I mean?
Yes and no. There's no.
Well, let me put it this way: everything that is flying on a manned mission has been conceived 10 years or more before. Because
Exactly.
you need all space qualification and things like that. Now, when we are using here on Earth on simulation always in the latest gadgets, at some time this must flow into an operational concept, which is a basis.
Super good point. I mean, I think that we're struggling with that as a whole because, and you notice I have been doing recruiting,
Mhm.
and you know, so many people, we don't have a unified concept, and we need to start here. We've done, what, like 12 years of work all over the world, and yet we haven't sat down and tried to unify what we're actually going to do once we do this.
So we are saying, we as a Mars Society, we are saying we are testing all kind of available equipment, and later on we will see if it is useful or not, but we try it out.
But it might be time, you're right, it might be time now to start taking all that knowledge and unifying it into something. I would actually really love to see that, a unified concept that we practice.
Well, and that's kind of what I did with this, back up here a little bit.
And by the way, that's not a rover, the drove is a robot.
It's a robot, yes. And actually that's what it's called in my other presentation I just did for a bunch of around. Yeah, the robot, yes.
Yeah.
But that's what I tried to do with this slide was, okay, where can you put gear and how much? And what kind of gear can you put in that location? So this was sort of my grand unified periodic table of where do you stick stuff. But you know, one thing I would love to see on future suits is multi-gear or multi-strap integration.
Well, that's why I'd like you to talk to the teams, you know, because they're doing it right now. So
Okay.
this would be the time to
Mhm.
put those.
And as I said, I understand the Mars Society is not NASA, and there is a much more limited budget for these things. So I'm trying to find ways to.
We're not using that.
No, we're not doing so good.
Yeah.
Okay.
We've loosened our.
Okay. Slightly. Okay. Well, I want to keep them. You know, that loosening them slightly is not the same as
We still don't have an answer.
yes, as oh happy days, but.
We're doing better.
You know, well, then a $50 piece is not necessarily out of the question. That's the real question. Yes.
Yeah. As Italian Mars Society, we would like ourselves to procure one of those simulated suite to try to field test some of the projects we are bringing forward. So what would be your suggestion? Can we, for example, try to use exactly what is used now at MDRS, or try something else, or you have any suggestion on this?
You know, something I would like to see is an open source design, where we tell you exactly how to make an MDRS suit, and we put those plans online. Because
So we will
if I
have
was,
our older suits available, and about half of them are operational.
Okay.
So we'd be willing to
Good.
pass them on.
Yep, fantastic.
Yeah, as a good start. There's been what? I mean, a counter pressure suit and then our simulated pressurized suits are the two main models. One of the reasons we used to have these big bulky gloves, right, on our pressurized simulated suits. But on a counter pressure suit, you don't need that. And that's why we've gone to instead of big boots and big gloves. So we really already have kind of a cheating hybrid suit. And there's been a lot of spacesuit research done, not lately, which is why I was so excited about giving a talk, because we've got away from this a little bit, and we probably need to go back to it. There's a lot more data out there. So I think that we can benefit from more field work, but we can also benefit from an overall review of what's been done already. I mean, we have to realize at some point that we've been doing this for a long time. There's a lot of stuff out there. But yeah, let's talk, because we do have suits.
and I realize I didn't quite answer your question, so I'm going to circle back. What I would like to see is, you know, when I say put a smartphone there, I'm speaking in kind of generic terms because we were able to use a program called Gaia and another program called Theodolite to get those wonderful in situ data capture. What I'd love to see is when, like, you know, there's God knows how many app programmers out there who would love to have something worth doing. If somebody went and built something where it would capture the camera and your voice notes and your voice recognition and all that, then you would have the ability to log a mission in terms of, okay, I'm looking at this rock and I'm telling you about this rock and I'm taking a picture of this rock, and all this stuff, including the voice notes, is all getting logged together. If you could then integrate a drone, whether it's streaming real video down like a Parrot, which is $300, or doing just captured video like my brother's thing, which is under $20, but it's this big, then that's another question. I assume that on Mars you would probably have something that would stream video down to something on your wrist, perhaps. That said, I'm not taking that technology out there because I have a sudden urge while I'm cliff climbing to play Angry Birds. I'm doing it because I want to have better enablement. So my background is in business analysis, which is a little different than it's the business side of what you're doing on the European Space Agency side. What I would suggest is something. My background is I would make a use case of these situations. I would have a happy path and then the various alternate flows of I'm going to use this for this. However, I can also use it for these other 5 things. I can use my rock hammer to fix something on my ATV if I really have to, that sort of thing. I would have that mapped in mind in choosing my gear for a 10 years later we're going to take this to Mars set. But that's my background. I'm sure you have a different take on some of that stuff as
You
well.
would adapt the equipment to the specific task or a certain mission.
But the old expression is, no plan survives contact with the enemy. You don't want to get too locked in on a plan because it will not survive, especially even in the desert, let alone on Mars, under the circumstances.
No, I mean you would adapt your scientific mission or an exploration mission as a whole. The equipment required for the astronaut is different. That would be adapted corresponding to what the task is.
Yeah, one thing I cut out of this thing for time was I had an idea for, what if you had a miniature chest pack that did everything the MDRS backpack did, but instead of having, the big batteries, you would have the batteries that you would have for, like the same lithium batteries I had on that power truck. And you might have to swap them about 2 or 3 times, but that would also be insane. Because if I had a chest pack that was like absolute minimum life support, but I had the swappable modules for CO2 filtration and for like a liquid oxygen cartridge and a power cartridge, that would be a perfect emergency escape system for, one, I can sustain myself in the field indefinitely because I can swap cartridges, and 2, if I have to crawl through like wreckage, I can do so with this much smaller pack. 3, I can climb cliffs, 4, I can boost the range of my backpack on normal operations. And 5, I've got batteries that are compatible with my power tools and compatible with my remote side stations and stuff. So there's a lot of ideas there of let's just have a collection of uniform equipment where we can swap things around and we don't have to have a NASA budget to do that sort of thing. Oh, and the other idea I had is let's have a slot up on top that is compatible with a small 3D printer so that if you want to build your own electronics box up top or whatever, you have a place where you can just clip it into place. So, any other questions? Yes?
This is a little bit outside of the subject, but it relates to the business of all having an alternate helmet, having a motorcycle helmet. We as a group, we discussed that because we have some ideas about it, and a lot of it was brought up with
Actually, I was in the long version of this, the longer version of this when I was originally writing it, I had a whole thing about helmets. Because a standard spacesuit helmet is just like MDRS, and it's like that. You turn your head in the helmet. You don't turn the helmet. There is the only suit helmet I know of where you turn your head in the helmet, where the helmet is attached to your head, is the suit that's used on the SR-71, which is not pressurized most of the time. It's only pressurized in an emergency. So the pilot can turn his head and do his work, but in an emergency, it pressurizes the suit. He can barely turn his head once it's pressurized. So there's a big issue with the cog, and that's one dimension. If you want this ability, then there's the thing there. And I realized something when I was writing that section that's kind of interesting. I was reading up on this new Xbox One, and it's got this really advanced Kinect sensor that said it can read your heart rate. And I'm like, what do you mean you can read my heart rate? And it turns out there are real micro movements in the head that indicate what your heart rate is. And it's measuring these micro movements in how your face is moving to indicate approximately what your heart rate is. And I realized how many micro expressions do we have when we're talking face to face of, oh, I don't understand, or what's this. If you lock somebody's head down, you've lost a good chunk of your nonverbal communication skills when you're talking to somebody. NASA loved some movie, I forget which movie it was, but they put LED lights in the helmets. And so you could see the astronauts' faces when they were doing it. And it was like, wow, that's great, you can see the guy's face. What made you think to do that? And they were like, well, they're actors. If you can't see their faces, what's the point? And NASA was like, well, we kind of would like that to have nonverbal communication from helmet to helmet. When we're on EVAs working on the space station. So there's a lot to that. And I think they're actually, because I came full circle on that, because I thought, I hate the fact that you have a limited field of view. I could not see, I had to train myself where this hip holster was. Because once I put the helmet on, I couldn't find it. I couldn't see it. And it's right here, But if I put a helmet on like a motorcycle helmet, I can actually rotate my field of view to match my head, I may lose a bunch of nonverbal communications. And the other question is, if you actually lock somebody's head down in a pressurized environment, then are you going to lose the ability to... The way the human mind works is you tend to watch yourself do things to form your self-image, to form your memories of what you're doing. And it seems counterintuitive because you think, I think, therefore I do. No, it's I think I do, and then I watch what I just did, and I watch the results, and that's how I form my opinion about myself and what I did. If you are restricting somebody's head's movement, are you really having the full experience of going to Mars? Because are you locking out a part of the person's psychology? It's just something I thought about when I was doing this. But I'm sure we're out of time. Yeah, I'm slightly out of time. Thank you.